Solve two unknowns. When solving problems, we know that sometimes there will be situations with more than one unknown. For example, Tony is making maple syrup. Last week he spent $162 for 12 maple syrup buckets and 3 lids. He remembers the total, but not the individual prices of the buckets and lids. If X is the price of the buckets, we know there were 12 of them, and Y is the price of the lids, and we know where there were 3, and we know that the total was $162, then we can make the equation 12x plus 3y equals 162, and we can calculate possible values of x and y, but we can't know the actual price. But what if we had more information? What if Tony remembered that the price of the buckets was $4 less than the price of the lids? So now we can make a second equation. The price of the buckets plus $4 is the same as the price of the lids. Or you could rewrite that by rearranging the formula if you want to have it as a xy, as x minus y equals -4. Let's restate the problem. The price of 12 buckets and 3 lids is $162, and the difference between the price of the buckets and the lids is $4. And we can represent this information in two linear equations. 12x plus 3y equals 162, and x minus y equals -4. We know these are linear equations because they have two variables. There aren't any exponents or anything like that. Also, in both of these equations, the variables refer to the same thing. In both of them, x means the price of the buckets and y is the price of the lids. Now, there are 3 methods that we can use to find the value of x and y. These are substitution, elimination, and graphing. The first method is called substitution, and in substitution we isolate the variable in one equation and then substitute the value into the other equation to find an answer. So looking at the two equations, I'd start with the second one because it's simpler. So let's isolate y on the left side. We know that the lids are $4 more than the buckets, so x minus y equals -4 is the same as saying that y is equal to x plus 4. Now we can use this value to replace y in the first equation. So now we take our first equation and we substitute x plus 4 for y. So we've got 12x plus 3, and then in brackets x plus 4 equals 162. And so we're going to use the distributive property to get rid of the brackets. So we've got 12x plus 3 times x is 3x, and 3 times 4 is 12. So now we combine like terms, and 12x and 3x is 15x, plus 12 equals 162. We subtract 12 from both sides, gives us 15x equals 150. Divide both sides by 15 to get x equals 10. So now we know that the buckets were $10. Now that we know that the buckets are $10, we can substitute that value for x into the first equation to get the answer. So y is equal to x plus 4, y is equal to 10 plus 4, y is equal to 14. When we have two equations that share the same variables, it's called a system of equations. And another method that we can use to solve a system of equations is called elimination. Now, before we get started on this, let's think about why it works. Now, if you think about the principles we know about equations, if you do something to one side of the equation, and you also do it to the other side of the equation, then the equation will still be equal. So, for example, take 1 plus 1 equals 2. If you were to multiply both sides of this equation by 2, it'd still be equal. So 1 times 2 is 2, plus 2 times 2 is 2, equals 2 times 2 is 4. Still equal. Another thing is that since both sides of the equation are equal, we can also apply this principle to add equations. So we could actually add these two equations. So 2 plus 4 is 6. And we could add the other side, 1 and 2 is 3, plus 3 equals 6. And since we're doing actually the same thing to both sides of the equation, everything's still equal. So I don't know if that helped, but we're going to use those same exact principles with these two equations. And we've got them arranged and lined up so that the x's and y's are above one another, and now we're going to multiply one or both of the equations by a factor that will allow us to cancel one of the variables. And this one's pretty straightforward. We just need to multiply the parts of the bottom equation by 3. So if we multiply 3 times x, it's going to give us 3x. And if we multiply 3 times negative y, it's going to give us negative 3y, and that's why we used 3, because we've got positive 3y and negative 3y. And then negative 4 times 3 is going to be negative 12. Okay, so we've multiplied both sides of the equation by 3, so everything is still equal. And now we can add our equations. So 12x plus 3x is 15x. Positive 3y and negative 3y cancel out, so they are eliminated. And 162 minus 12 is 150. Does that look familiar? So now we just need to solve for x. So we divide both sides by 15 and we get x is equal to 10. Now that we have a value for x, we can substitute that value into one of the equations and solve for y. So we'll use x minus y equals negative 4 because that's easier. So we've got 10 minus y equals negative 4. Subtract 10 from both sides gives us minus y equals negative 4 minus 10. Negative y equals negative 14. Negative y means negative 1y, so we just multiply both sides by negative 1, and we get y equals 14. So now again, we know the buckets were $10 and the lids were 14. Another method to solve systems of linear equations is graphing. We can draw a line on a graph that shows all possible values of the variables in a linear equation. And if we graph two equations that have the same variables, then the point where the lines cross will be the point where the possible values of the variables are the same for both equations. Now you're going to start by making a table of values for each equation with at least two ordered pairs. So let's take 12x plus 3y equals 162. We might have to do a little figuring out here. Let's see what would happen if x were equal to 8. So that gives us 12 and 8 plus 3y equals 162. Which is 12 times 8 is 96, plus 3y equals 162. Subtract 96 from both sides gives us 3y equals 66. So y is equal to 22. Okay, so for the first equation where x is equal to 8, y is equal to 22. So we need at least one more set of coordinates. What would happen if x were equal to 12? Well, if we work it out the same way, we'll find that y would be equal to 6. So now we have 2 points. We have x8, y22, and x12, y6. So if we plot those 2 points and draw a line, it'll look like this. So now we need to find two sets of coordinates for the other equation. Now I'm going to just rearrange this because we know that means the same thing. Y equals x plus 4. Okay, so we're finding our table of values. What if x were equal to 5? Well, 5 plus 4 is 9. What if x were equal to 15? Well, 15 plus 4 is 19. So now again we have two sets of coordinates. Using those points, you graph the line of the second equation, and it looks like this. And you can see that the two lines cross at 10.14. So X, which is the price of the buckets, is $10, and Y, which is the price of the lids, is $14. All three of these methods can be used to solve systems of linear equations, and you should choose the method that seems like the easiest one to solve that particular problem.